Let me first go to the code camp just to show you guys that stuff. Yes, Atlanta Code Camp, probably atlantacodecamp.com. Sessions. Developer's Guide to Finding Optimal Solutions, a developer's introduction to Azure Active Directory B2C, a developer's introduction to Azure Machine Learning. They probably just copied everybody's. Oh, somebody who didn't say a developer's whatever. Authentication using OpenID Connect and how to automate design patterns with PostSharp and object-oriented programming. That should be fun. Automated website testing using Selenium. Azure Service Bus in action, better code in 4 easy steps, building websites using ASP.NET Core, Docker, and Azure. This is just a bunch of things that, depending on where you are, let me see what was the registration. I think $10. Maybe they don't return them. I think in some place I saw they wouldn't charge you if you, but if not, it's $10. And it includes foodish or something like that. Just if you happen to not have anything to do on a Saturday. It's probably very worthwhile, even if it's just to get to meet other geeks and to hear keywords that you won't quite get, right? It's not a bad idea to get a clue so that the next time somebody mentions Docker or ASP.NET Core or MVC, you at least know what they are. Just. Yeah. I am terrible at naming my modules, by the way. Module 7 is defining classes, it's not arrays. I was confused. Hopefully I named it right in D2L. Maybe, I'll go check. Last class, we talked about objects and using objects, right? Now we are going to see how we can define our own classes. A class is like a template for your object. Every object belongs to a class, and a class defines all the fields, the variables that it contains, and the methods that it has. And then each object would be a member of a class and would have its own separate state. Does that make sense? Yes-ish? Cool. One important thing. Well, let me the standard example, right? What would be examples of a class? String is a class, right? What's an instance of the string class? ABC in double quotes, right? What other classes? Boolean is not a class, maybe. Boolean with capital B is, but Boolean with lowercase b is a primitive, which is not a class, right? In real life, you model your domain with classes, right? If we were trying to make a system for controlling classes, courses, and students and things like that, right? What would be our classes? We'd probably have a class for student, right? And the instances would be you guys, right? Or well, our representation of the computer of each one of you guys. Does that make sense? The class is the general set, right? And it defines kind of the skeleton of what does each contain. So for a student class, we would have your name, your social security, or your student ID, those kinds of things, right? So we know that for every student, we are going to have those values. That idea makes sense? In Java, to make it easy, for the most part, you can cheat now with Gradle and your IDE and things like that. But for the most part, for any public class, your file name needs to be the same name as the class name. So if your class is person, you're going to have a file called what? Person.java. Does that make sense? Moreover, your folder structure, your directory structure, has to go with your package structure. So if you define a package com.okaram.student services, right? And inside there you define a person class, it needs to be in a folder called com/okaram/student services. And the thing will need to be called person.java. Does that idea make sense? Why do we use packages? To group our classes, right? We have been seeing the packages as in somebody else defines a package and we import it. This is the same thing. Now we are the guys who are defining stuff. I still cheat and use non-public classes or static classes, inner classes, and put them in one file many times just for convenience. This is actually horrible practice, and in reality, you normally create one file per class. And that actually makes it very easy to find where your classes are. If you know the name of your class, you know where it is in your file structure. Does that idea make sense? Cool. So here's the basic syntax. You define a class with, terribly surprising, the keyword class. Then you specify the name of the class, open braces, close braces, and then you put the fields, which can be either variables like this, or we'll see they can be methods. This looks almost like variable declarations outside of a class, with the thing that we need to specify, or actually we don't need to, but we usually specify an access modifier. And for the most part, if we want stuff to be public, accessible to everybody, we declare it public. Does that idea make sense? So I can, let's see, shall we play with it this way? File, new project. No additional anythings. This is terrible. Com.company sounds good as a This is actually IntelliJ rather than Eclipse. My Eclipse is still broken on this machine. Sorry. Okay. It has source. So in here, I can create person.java. It is in this folder, so it has this package declaration, right? And here I can cut and paste this stuff. In my main.java, how can I create a variable of type person? Person p1 equals new person, right? Since I didn't declare a constructor, the default constructor is there. And then I can do p1 dot first name equals Lando. Ah! Okay, I'm handsomer, I know, but what can you do? I'm modest too. Does this make sense? Seems similar is the kind of stuff that we have done, right? Notice that each person has its own first and last name, right? So I can create person p2 equals new person, and then p2 dot name equals Oscar. Ah, there's no name. I'm an idiot. First name. It's misspelled, but I'm not gonna put accents. Just in case. I'm not asking. Yeah, why is it complaining? Not a statement. Ah, that's a minus. Does that make sense? Each individual person has its own first name, last name, and age, right? This is cool? Cool. So this stuff. Now, I can define methods. Actually, I could a very simple get first name, right? That returns, and the keyword this means the object on which this thing is operating. Does that make sense?
Do you always have to use it to reference a method variable?
No, actually you don't have to use it.
Okay.
I tend to use it in this class because I think it actually makes more sense when you start to write it down, but you don't need it. In fact, most people never put it, except when you distinguish between parameters and instance variables. But normally you don't have to put it. Does that idea make sense? In fact, we could write it like this. And by context, Java knows that that first name is the first name of the object that this is operating on. Does that make sense? If I define this, then I can come here and do and what do I expect to get printed on the screen? Which persons? Orlando, right? Does that make sense? Maybe I can even figure out how to run these things. Huh? Yay! Does this idea make sense? Any questions? No? This is basically, if you really get this, then you're done. Then all the other stuff is kind of irrelevant-ish details. Could we do a get last name? What should we write? Last name. Or how do you like it better? This dot last name or just last name?
I like being explicit, so
I think at this point better to go
Explicit?
over the top but overly clear, because
Yep.
when you get more familiar, you can just streamline it.
Works for me. Many times in object-oriented stuff, I'm not very big into it, but we do these kinds of things, right? We have a setter. Oh, thanks for telling me. And a getter, right? Once we do that, we really don't need to make this guy public anymore. And I can make it private, right? Because now you can call those two methods to them. In the object-oriented religion, you should do it this way. If you're just a programmer, then you don't have to. What's the advantage of doing this? Of having a getter and a setter? The main advantage is that you can change the implementation, right? Now I can maybe store it all uppercase, right? To guarantee that, or store it in camel case, right? I can guarantee that the first name, the first initial is always uppercase, right? I can replace spaces with dashes, those kinds of things, right? So now I have this magical layer of indirection that I can later on change. Normally, when you're doing a piece of software, you know whether this stuff is going to change. It's a pain in the neck to change it later on, because you need to change all your clients, but normally you know whether you need to change it or not. So you can get away with not doing this for a bunch of things. On the other hand, your IDE will generate these things for you. Yay! In this class, I strongly recommend you don't let your IDE generate stuff because you want to get your fingers trained. We can also do methods that do useful stuff. What if we want to return the full name? What would we return? Does this make sense? So after we do this, we can do this stuff and then run Shift F10.
Might not like it. It's not a private.
Oh, it's complaining? Yeah.
Is it private?
Oh! Oh, this guy is private. Ah, it's public again. For now, at least. Yay! Does this make sense? Yes? Cool. Just for fun, let's do this one. Like the formal full name, the last name, comma, and then the first name, right? So how would we do this? Do we put spaces? Probably. I don't know. They're not smart. They autocomplete the dumb way. But oh well. Makes sense. Simple, easy, cool. Slight magical thing. Constructors. A constructor is what we use when we do new, right? This kind of stuff. And it can help us guarantee that the thing gets initialized. Because if not, what does it get initialized by default? Before we do this, what's P1's first name? Who knows? Probably the empty string, maybe null. We don't really, well, you know, you can go look at the spec and decide what it is, but it's basically garbage, right? So, what you can do is define your own constructors. A constructor is almost like a method, except that it doesn't have a return type and it's always the same name as the class. Does this make sense? Once we do that, we know what it got initialized to. You can also, if you remember, we did method overloading. You can define a method that takes different sets of parameters with the same name. You can have constructor overloading, where you have a constructor with different sets of parameters, and that allows you to create objects in different ways. So probably would make a lot of sense to have a person object that takes string and initialize, right? Now, there is a slight problem with this, That's always, and it sucks either way. I'm going to tell you the problem and tell you my solution. And then I'll tell you the other solution. What is the obvious kind of parameters that we would pass, right? The same as my fields, right? So what are the obvious names for those things? Well, the same as my fields, right? But then I get confused. So there are two solutions. One is mangle the names, right? Like, oh, I'm going to call it P underscore first name, P underscore last name, and P underscore H, right? It is obvious what they are, but now they have a horrible number. You can also, what many people do is the reverse. They mangle these guys. So this become underscore first name and underscore last name. I don't like that. It is mildly useful because you distinguish always between instance variables versus parameters and things like that, but I don't like it too much. What I tend to do, and it usually doesn't confuse me, is to use this. And Java does the right thing. Does that make sense? It is slide by manners. I tend to not call my fields with the same name as parameters because it is confusing, except in constructors and setters, because that to me makes sense. Either one of the three options is okay, right? You can mangle your parameter names, you can mangle your variable names if they're never going to be public fields, so they don't have to have a specific name, or you can use this keyword to distinguish between the parameters and the instance variables. Does that make sense? Is it okay if we use this for the examples? Sure, why not? If it makes you angry, change it.
Is that part of the Java standard that Java will recognize it, or does it vary entirely?
What is what part of the Java standard?
Being able to say this is not first name equals first name.
What Java says basically is if you just put first name and there is a parameter, the parameter wins. Method parameters win over class variables. That's basically the Java standard. That's part of Java. So you can use it all the time. But
So it won't vary from compilers.
no. It is part of Java. Yeah. In fact, even this idea of the getters and setters is almost part of Java. It's not really part of Java, but it's a very, very strong standard. A bunch of libraries assume that this is what you're going to call your methods and things like that. We have now talked about methods and constructors, right? Access modifiers. We can have actually 4 different kinds of access. The first one is if you leave it alone. I think this would actually work. Yes. If you leave it alone, if you don't specify an access modifier, you get the default, which is called package. Every class in the same package can access the variables. Does that make sense?
Can you explicitly declare this?
No, there is no way, there is no package keyword for access modifier. If you don't put it, it's package. If you put anything else, then it's something else. Public means everybody can access, right? Private means only you and your methods, only methods inside the class. And then protected, we will see in a couple of classes, is for when you have inheritance. Protected means you and your subclass. We'll see what subclasses are and what does that mean. You will eventually, probably in the next class, you'll take C++. It is almost the same in C++, except that in Java you put it for every field. In C++ you put private colon and then list all the fields. But it's almost the same syntax. Now we can explain a secret. You can also use the static modifier for things that belong to the whole class. If you define a method as static, right, then it doesn't need a reference to an object. You don't need to have p dot whatever to call it. You don't need to have this. In fact, you don't have this, right? Yeah, that's basically it, right? It belongs to the whole class rather than to each instance. You don't need an instance to call the method on. If you put it on a variable, then the variable belongs to the whole class, and every instance of the class shares the same variable. Does that idea make sense? So we can do stuff like does this make sense? I'm declaring a static variable called numPeople, right? In my constructor, I'm incrementing that variable, and then I have a method that returns that variable. So in here, I can then do, actually, first of all, I can do this to make my code nicer. All right. I tend to always define constructors because I find this a lot nicer than the other way. Now I can what do I expect to get? I'll get P1's get full name, so that'll print Orlando space Bloom. I'll print P2.get formal full name, so that'll print Oscar Garcia, Oscar, and then I'll print P1.get non-people. What would that print? 2, right? I have a static variable that I initialize to 0, and for every constructor I increment it, so I incremented it twice. Does that make sense? What would P2.get non-people print? 2, they're the exact same variable, right? P1 and P2 are 2 different instances of people, they both share that static variable. Does that idea make sense? So if I run this, does this idea make sense?
So if you did the first half of that print line right after you instanced P1, and then you did it again after you instanced P2, that exact same line.
Yes, sort of, kinda.
I mean, not just P1, not P2.
Yes. If I do this, I would get 1.
Yeah. And if you did the same thing after that, you would get 2.
Exactly. Does this make sense? Maybe. She won't hold it against me too much. Oops, because I'm printing P1. Oh, well, yeah. Wouldn't matter, right?
No, it doesn't matter.
But let me do this. Now, here's the deal. What happens if I do this?
They each print 1.
What's going to happen here? They all print 1. Why?
Because it's now a member variable, not a.
Now each one has its own copy, and so each copy gets only incremented once. Does that make sense?
Yes.
I can also do this, declare that to be static. I think, let me make sure that I'm not lying to you. Yeah. My method is static, right? So what this now allows me to do is also do person.get known people. Does that make sense?
Yes.
Now, what happens if again I try to change it to this, right? I'm gonna get in trouble because now that method get non-people cannot reference non-people because non-people is not a static variable anymore, which means that I need an instance. I cannot be an instance method, static method. Right? Get non-people cannot be a static method because it's trying to access an instance variable. Right? Make sense? Reasonable sense?
No, a static method declared inside of a class brings. Does it have access to private memory in that class?
Yes. So you could take an instance as a parameter and then you have access to everything inside that instance. And that's pretty much the same in every one of the C-ish languages. Same in C#, C++. All of those guys. So now we know about static modifiers, right? And we have also talked about getters and setters, right? One of the big ideas of object-oriented stuff is this encapsulation, right? You put together into your class your state, your instance variables, and your method, your behavior. You put together state and behavior, they come in one package. In order to promote encapsulation, the old religion would have you never have public variables. In practice, it is not a bad idea to get used to it right now. Eventually, that may not be the right idea. It's not a bad default. But it's not always necessary. Trying to remember, I don't think I make you guys do fractions, so we can do it as an example. Do we want to create a point class just because we're familiar with it? Nah. Shall we create a, I like the fraction class. I'm just hopeful that I'm not using it for any of the other assignments. Hopefully not.
Not on this week's assignment.
Not on 7, yeah. So hopefully I'm not using it. But if not, oh well, I've just destroyed myself. If you are a fraction, and actually, maybe that's not the best example. Maybe you guys can suggest something. Because I tend to use fractions because, well, everybody knows fractions, right? But maybe you guys hate math. You probably shouldn't be here if you hate math, but maybe you guys have better examples. No, fraction's good enough. Doesn't trigger anything to anybody. Okay. How can we represent a fraction? What do we have? Numerator and denominator, right?
Yeah.
The stuff above and the stuff below the division line, right? This is our constructor. Let me actually make this private. Then let's define public getters, right? What do we return? Or just numerator, right? How do we transform it to a decimal? How do we transform that fraction? How do we get the decimal value of a fraction? And then
divide by 4.
right? I divide numerator by denominator, right? So if they were int, then I get integer division, which is not what I want. So I need to do int of denominator. This makes sense. How do I create a fraction? Fraction variable. How do I create a variable of any type?
Class name.
Yeah, type name and then, right? And how do I create an instance of a fraction?
New fraction.
And I need to pass the numerator and the denominator, right? And it's complaining. Maybe that, oh, this thing doesn't quite work yet. What does it like?
Structure type name.
Thank you. My constructor cannot have a return type. If not, it's a method. So maybe. Ooh. You haven't reached end of file while parsing. Okay. Woohoo. The only slightly ugly thing is what happens when I do this. Actually, maybe we probably ought to do cooler stuff. There's two methods that every class should have, right? Normally. Which two methods? You remember? ToString and equals, right? What can I do? How do I know if two fractions are equal?
You can convert them to a percentage and they're the same percents. Or to a decimal rather.
Convert them to a decimal and see if they're the same decimal. That could sort of kind of work, except that decimals are ugly and squishy. You may not get the same thing. For now, let's do dumb things and then we'll fix it.
Been there, done that.
Does this make sense? They have the same numerator and denominator, right? How do I transform a fraction to a string?
The quotation marks plus the thing.
What? Plus what thing?
Oh, plus whatever it is you're converting.
What is it's a fraction, right?
Yes.
What do I do? If a fraction has a numerator 3 and denominator 2, what do I want to have as the string representation?
Quote, plus this dot numerator plus that division symbol plus this dot.
Actually, I don't need these first quotes. This makes sense. Now if we do something like 1/3, sort of kind of equal that. Does this make sense?
Yes.
Cool. Now the only thing we really need to do, right? Your idea about comparing the floating point values, right, is reasonable, but we also get ugliness, right? Imagine that I'm doing this, 1/-3, right? What do I print? 1/-3, that's ugly. How do you print it in math? What did they beat you in elementary school to do it, right? The minus goes,
Yes.
right, outside. So it's -1/3, right? You always get to normalize your fractions, right?
Right.
They usually call it simplify, right? You sort of simplify your fractions, but you're really normalizing, right? You are also keeping them on a particular way. So that may be, and this is also a good, so let's do this. God. Actually, let me do this. Int sign equals mass dot sign. Signum, no. Gar.
SGN.
No. Okay, we can build our own, right? That's cool, right? It's not quite right, but that's all I care. Actually, okay.
One has to be a negative one.
So what I really want to do is Boolean right? And that is actually not quite this sign in math, but now the other one that I need to do is get the GCD, right? Did we ever do this as an example? Yes, right? So if n2 is 1, right? We return n1. Otherwise, we return GCD of n2 and n1 modulo n2, right? That probably works. Oh, 0, not 1. And if not, we go get it from Wikipedia. Yay! Sort of kind of works, right? Okay. So in order to normalize, we can actually no, not minus, equals minus. Or just slash equals GCD. Now this allows us to do this. And now everything is beautiful. No, it's not beautiful.
How's it? Doesn't GCD take arguments?
Sorry?
Whatever. Yeah, like divide equals G. Oh. Alright, no, that's good. No, yeah,
Ah. I'm still doing the wrong thing. Yay! And now our equal works because I just need to compare numerator and denominator because I'm storing things in a normalized way. Is this cool?
Pretty cool.
Other stuff is left as exercise to the reader. Go do addition and subtraction and multiplication, division of fractions and all those kinds of things. But, this is about it. Any questions on classes and objects in general? Now, the next assignment requires you to define a bunch of classes, 2, 1? Just the turtle thing, right?
Yes.
Just one class, a turtle class that has an X and a Y. And then move the turtle, right? And change the X and Y coordinates of the turtle. And that is it. I will see you guys on Wednesday. Yes.
Can you show me about non-static variable cannot reference to the static content?
Sorry?
Non-static variable cannot reference to the
A non-static function cannot. A
Function.
static function
uh-huh.
cannot reference a non-static variable. One sec. Let me try to find this thing
Okay.
and see where it is. Ah, there it is. Finally.